Okay, I'm here now at Microsoft Research with David Stern and Jürgen van Gaal, and we're going to be talking about their use of F# on a project that they're currently working on. So David and Jürgen, could you say a few words about the group you work with or work in at Microsoft Research and its area of focus at the moment?
The lab that we're working is called Fuse Labs UK. So Fuse stands for Future Social Experiences, and essentially it's a group of people in Redmond, Boston, and here in the UK, where we're developing sort of new technologies around social experiences, social networks, etc. And sort of the focus for the group here in the UK really is everything that's to do with sort of machine learning and data mining. So how can we sort of use intelligence to sort of extract things from data and use that for social experiences.
Fantastic. So you guys have been working on a project called Project Emporia. Perhaps you could say a few words about what Project Emporia is and what it's aiming to achieve.
Sure. So Project Emporia is about filtering down the massive amount of content that's in the real-time web in social media. So people, who would be overwhelmed by the amount of stuff coming in can actually really focus on the cream, the stuff they're really interested in.
Right. And we're talking about Twitter here, blogs.
So initially we're focusing on Twitter,
right.
But later we're going to branch out to other areas such as blogs and Facebook.
Fantastic.
So the sort of motivation for Emporia is that while there's maybe like 60 million tweets every day on Twitter,
wow.
Actually most of the users don't post very many tweets.
Right.
They mainly are interested in reading. So we targeted Emporia very much at people who are more interested in consuming rather than producing content.
Okay. Now, as I understand it, F# has played a key role in the development of Project Emporia. Could you say a few words about how F# has been used and how it's enabled you to get to where you are today?
I think the starting point for us really is, this sort of exploration phase, data exploration phase. So generally when we sort of tackle this new problem or new project, then there's this sort of, pipeline of getting the data, exploring the data, and these things change. The things we're looking for change fast. We have to do data manipulation very easily. Very often it's string and text manipulation, those kinds of things. So there's a whole this whole exploration phase is something where something like F# has really enabled us quite a bit. For example, the F# interactive mode where you can sort of change things on the fly and that happens. Those are sort of things that we use in the very early stages of a project. And I guess as these projects mature, then we start using F# more to build sort of library components or things, small components that could be reused later on. And then generally, we use those F# components in a bigger system. I don't know, maybe you can say more about how it's done for Emporia exactly.
Yeah, so I think that's all absolutely right. It's very important in the exploration phase. But also as the model becomes more mature, as we start to actually put components into Project Emporia, an advantage that F# has is compositionality. Okay. So you can drop in different functions that perform particular purposes in the model and swap them out on the fly. So even though Project Emporia is now publicly released, it's still an experimental thing. Right, so we're still changing things all the time, and this compositionality makes it easier to play around.
Absolutely, and as you've gone, you've built up this library of functions that you can then put together in this compositional fashion, as you mentioned, and potentially even let users build up interesting levels of composition in terms of what the data is telling them going forward.
Yes. Yeah.
Okay, excellent. So David, you've drawn up a quick back-of-the-envelope architecture of Project Emporia. Can you talk us through the key components very briefly?
Sure. So the front end of Project Emporia is a Silverlight client, which is what you see. Yeah. And that communicates with a query service at the back end that provides the filtered content from the social feed from Twitter.
So this is taking the feed from Twitter and filtering it right down to something manageable for the UI.
That's right. And actually there's a component I missed off here, which is called Twig. which is what processes the Twitter fire hose and feeds it into the system.
Right. Okay. And you've also got a couple of little boxes with M written on there. Can you say a little bit about what those are?
So that's Matchbox,
Okay.
which is the recommendation system which actually predicts whether a particular tweet will be interesting to you. And that's actually the part that's written in F#.
Okay. So one of the things that's really interesting to me is understanding that F# doesn't have to be the entire solution. We've got Silverlight as a front end because it's appropriate for that to be the case. We've got databases on here, we've got other engines, but actually it makes sense for you to use F# in some areas. And is it possible to expand at all on why F# was actually really good for the Matchbox filtering component as opposed to perhaps some other languages that you could have chosen?
Yeah. So F# was particularly appropriate for the Matchbox. For the Matchbox part, for several reasons, I guess that we covered already, but that it's very good for expressing data analysis, for initially sort of developing the model and prototyping the model. But then it also gives you the compositionality you need to later on have flexibility to try out different components in the model. But the simplest way of using Matchbox, and so this system runs in Windows Azure, and the simplest way of using the model at the moment was to write some of these components in C# and then reference a Matchbox library that was written in F# rather than writing the whole thing in F#.
Right, and these would be running in worker processes in Azure, or
so these are a mixture. So these are web role services, and this is a worker.
Okay. So you've got a mixture there with an F# library being referenced from other C# components, all running in Azure, delivering the architecture that is Project Emporia.
That's right.
So I've also heard that F# is extremely good at working with data. Can you say a few words about how you've used F# to manipulate data in Project Emporia?
Right, so a lot of the sort of machine learning components like Matchbox, a lot of the work it does behind the scenes is sort of heavy duty number crunching. One of the nice things about F# is that it's sort of very well tailored to this sort of type of computation. And hence it also makes sense for us to keep these components in F# because it's sort of much better suited to this type of work than some of the other languages.
And obviously you've got a database there as well, so is there any guidance you can give in terms of, do you use a database to do a lot of the core data manipulation, or do you use an F# library to use a lot of the core manipulation? Is it a temporal manipulation that's particularly good with F#? What are you thinking in terms of do I go database or do I go F# libraries for manipulating data?
Yeah, that's a good question. I think a lot of the sort of run-off-the-mill type of computations can be done in the database, but I think, I don't know if you'd agree with that, but I think one big issue for these, this is an online system, right? So one of the big issues of these things is that everything has to be fast, everything has to happen in real time, and so we don't want to overburden the database with a lot of computation. So essentially what we do is really pull in the data, small chunks of data into the F# components, and I think there do the number crunching that needs to be done, and then feed it back to some of the front end.
And clearly that's going to map extremely well onto doing that in Azure, for example. You've got the parallelism inherent in F#, and you've obviously got the scalability of Azure. So that sounds like a really good match. And is scalability a key aspect of the Azure side of this?
Yeah, I think absolutely, and I think actually one of the big things about the great things about F# is that F# sort of puts you in a mode of programming that's very different. This functional mode of programming that's very different from anything that we've sort of done in the past, and one of the key ideas, sort of this notion of statelessness, of not mutating state. And that's incredibly powerful for an online system, right? Because the F# components, we don't want them to sort of keep state across time. We want every time that a person talks to the system does some computation, gives a result back, and it's ready for the next piece. So this idea of having a stateless component written in F# is very natural, and obviously that then fits well in what you can do with Visual.
Fantastic. Thank you very much, guys. Project Emporia. Hello, so I'm here with Anton Schweighofer, who works in the Microsoft Research Ad Center team. Anton, do you want to introduce a little bit about the work that you've been doing recently?
All right, sure. So I'm working for Ad Center, and Ad Center is one of the two big teams that contribute results to what you see if you go to bing.com. So the core search team provides all this content here, and the Ad Center team clearly is dealing with showing what is here in the ads block, on the top of the page and on the right-hand side of the page. My specific project is concerned with monitoring the whole, what we call the advertising ecosystem. So clearly, for advertising, we have like three key parties. First one is the user who goes to bing.com and wants something. On the other hand, we have the advertisers who would like to have ads for their products shown here in the advertising regions. And then we have the whole platform that provides the service, so Bing itself in a way. And in my work, I'm dealing with economic models that monitor the health of the overall advertising ecosystem. So how well off are users? Do they get what they want from a Bing results page? How well off are advertisers, and how well off is Bing? So there are various complex trade-offs that are to be made when optimizing what you see on Bing as a whole, so on the whole results page. And this involves coding quite complex mathematical models often. So if you see the equations written down on paper or on whiteboard, they would often fill the page pretty much. And my task is now to, well, understand that, code it up, make sure that it's correct, and then apply those models to data at the size of like a few terabytes or petabytes even.
So when you were thinking a little bit about which coding languages to use to code up these economic algorithms, did you have a short list of languages? What was your thought process to take you through to what ultimately was a choice of F#?
Mm-hmm. I've been for many years coding in MATLAB, which also allows you to express mathematical algorithms in a very concise way. But what we are dealing with here has often a much higher complexity compared to what I was working with before. So I think the F#'s killer feature for me in that context was units of measure that effectively give you a form of type system for real valued numbers or for integers. So any kind of numbers that you store. For example, these numbers could represent probabilities. Like, in that case, what's your probability of clicking on that ad if you see that page? So, in a traditional language, you would just say, okay, that's a double. Okay, fair enough. But there's a notion attached to that double. And in that case, it is the probability of a click given that you saw that ad. Other probabilities could be, okay, like once you've clicked on that ad, what's the probability that you spend more than, let's say, half a minute looking at what you then see afterwards? And again, that's a different probability. What F# allows you with units of measure is to avoid mixing those probabilities when it's not appropriate. So a probability of an ad click, given that you see that ad, is a different kind of beast from the probability of you actually staying there and maybe finding what you wanted on the landing page.
So presumably when you describe these algorithms in code, the fact that you are not having to spend so much effort in your code disambiguating your different units of measure, it actually makes the code much more readable, much more concise, and gives you the type checking, if we could use that word, of the measures being correct as well.
Correct. So the type checking is indeed the big advantage.
Right.
So having units of measure attached to pretty much each floating point number that I store saves me from having to write loads and loads of unit tests, for example. Because the compiler already tells me, hey, Anton, you're not supposed to add up apples and oranges.
Right. Yeah. So that presumably has saved you quite a lot of time. As you said, it actually saves you having to write some unit tests because you've got that type safe checking of those different units. That sounds like a real killer feature for one of the things you needed to consider.
It is, yeah. So it also gives you a bit of feedback then after you've actually also, so you may develop that mathematical algorithm for yourself.
Mm-hmm.
And it also gives you this additional safety check on whether you've done the math correctly.
Right.
So if the units of measure work out,
yeah.
as probably your physics teacher has taught you, the
Mm-hmm.
units of measure work out, then you're already in the kind of good region.
Right. Excellent. So units of measure, a great example of how they can be used to speed up the implementation of some economic modeling as part of AdSensor for Bing.
Mm-hmm. The other important feature I would add here is the ease of doing parallel computing in F#.
Okay. And parallelism is something that we've touched on a few times. And can you say a few words about how F# makes that an easier process, or the fact that
Well, F# encourages me to use immutable data structures.
Okay.
So when the multiple threads work on a specific problem, there is less risk of actually them running into deadlocking issues or something like that. So the code that I write would naturally be already immutable, so I can just spawn off a number of threads and have them do their thing, and I have to worry about less.
Right, so you don't have to go through the whole process of taking an existing set of code, making it stateless because it's already immutable, and then actually parallelizing it. It's an easier process. No sort of single switch that you can flip to make it run in parallel, but actually it's already in a state that enables it to be parallelized much more easily.
Yeah, well, it's pretty close to just flipping a switch.
Okay.
So just before I came here, I did exactly that exercise.
Right.
I had a bit of code that ran on a single thread.
Yep.
And within like adding 3-4 lines of code, I had it run on all of my CPU cores.
Fantastic. So parallelism, units of measure, a couple of features of the language that's really helped you in this particular project.
Indeed. So F# has helped me a lot, and I think if I didn't have F# at my disposal, the whole development time would have been by a factor of 2, 3, 4, something like that.
So significantly longer without those key features. Anton, thank you very much for your time. Hi, so I'm here now with Tor Greipel. Tor works in Microsoft Research in the Online Services and Advertising group. Tor, can you tell us a little bit about the work you've been doing with Ad Predictor specifically, and what your group covers, and then a little bit more about how F# has enabled your team and yourself to actually do the great work that you've done with Ad Predictor?
Absolutely. So in the Online Services and Advertising group, we're doing research on all aspects of the web, search, advertising, all of these exciting topics, typically covering huge scales of data, lots of users, so it's a very interesting area. And we're using F# pretty much throughout for a number of tasks, like the universal tool that we're using. And so one project that we've recently almost completed in a sense is Ad Predictor.
Okay.
And Ad Predictor really fulfills a key role in Bing and selecting the ads that are shown for a given search.
So this piece here, right?
So that's this piece here and also these pieces here, right? And basically what happens, a user enters a query, in this case Connect, and then of course the search engine needs to decide what ads will be shown. These are the kind of organic results, and we also want to show some ads. Now which ads get shown, that's the key question.
Yeah.
And of course we want to have a great user experience, so we want ads that people actually click on. And also the advertisers of course pay money